3 complex numbers. What is I equal to? Square root of negative 1. What's I squared? Negative 1. What's I cubed? They're in your notes.
We didn't have notes for 1.3. Yeah.
There weren't notes for 1.3. Good to know. Then we shall start with notes. All right. Imaginary number I. I equals the square root of negative 1. I squared equals negative 1. I cubed equals negative I. And I to the 4th equals positive 1. So if after you get to the 4th one, when you get to the 5th one, so I to the 5th would be back to the square root of negative 1. I to the 6th would be negative 1. I to the 7th would be negative I to the 8th would be 1. And then it would start back over 9, 10, 11, 12. So you could figure out a problem by figuring out basically what it's divisible by, and you'd be able to solve and tell me exactly what it's equal to. A complex number is a plus bi. This is what we call standard form. A is the real part. B is the imaginary part. And A and B can be like fractions or decimals or whatever. Also, they don't have to be like whole numbers or anything. If we have addition and subtraction of complex numbers, then I would have something like A plus BI plus C plus DI. So two things in standard form being added together. This would be equal to A plus C, that would be the real part, plus B plus D times I, that's the imaginary part. So notice the I is always written after the stuff that's being added together. Obviously, if there were numbers like 3 and 4 for B and D, then we would just say 7I. So just be aware of that. If we were subtracting, so A plus BI minus C plus DI, it's basically the same thing. It'll be A minus C. Essentially, I'm just distributing this minus sign through. And then plus B minus D I. So the only thing that changes is the negative in the between it.
What's the imaginary I for you?
It's the square root of negative 1. You can't have a negative under a radical. Multiplication of complex numbers. So if I have a plus bi times c plus di, what this is going to end up giving us is a times c minus b times d plus a times d plus b times c times I. Obviously, there's some in-between steps. Essentially, all they're doing is foiling, and then they're putting the real part in the front and then the imaginary part in the back. That's why it's written like that. So if you just straight up foiled this, we would end up getting to this when we simplified it down. And then next we have properties of complex conjugates. So if you end up with something like a plus bi times a minus bi, is what we call a complex conjugate, and this will end up giving us a squared plus b squared, because this is a difference of squares, so it's just the first term squared minus the second term squared, but because the I squared is there, it becomes positive. So a squared plus b squared. And we use this to get rid of I on the bottom of a fraction. So if I want to be able to like cancel stuff out, I'm going to use the conjugate so I can get rid of i's on the bottom. Much like we can't have a radical left on the bottom, I also can't have an I left on the bottom.